A very warm welcome to the people watching this video. I am highly obliged to represent my topic on concrete filled steel tubes. Today, I, Aviral Singh of Faculty of Engineering, Lucknow University, is going to represent my topic on concrete filled steel tubes. As we proceed further, we see the contents which I am going today represent in front of you has been listed. The very starting with introduction, then history of CFT, its component behavior, comparison, materials used, the use of pre-stressed CFT and its application, its advantage and limitations, with, with conclusion and bibliography. I may proceed further. The main question arises, what is CFT? CFT is nothing but a structure which have been developed with the mixture of steel and concrete to bear high capacity loads, which will be seeing further in this presentation. As we can see, concrete filled steel tubes are combination of concrete and steel. These are the steel tubes in which concrete is being placed, which improve its compression stress and ductility. CFT are of mainly six types. The diagram which has been represented on your screen, one of them is circular CFT, the another one is square CFT, proceeding with rectangular CFT, hexagonal, oval, and polygon. CFT has been used since last 50 years. The main use of the CFT has been in China. It was first used in 1966 subway of Beijing. CFT has been used widely in China as its bearing capacity and heavy load bearing capacity ratio. We will be discussing the component behavior of the CFT. As we have discussed earlier, CFT are of many types, but in those, circular CFT is more reliable and used widely amongst all of these because local buckling may likely to occur in square and rectangular cross sections. As we can see in the diagram, the hollow steel tubes outward buckling may occur, while in plain concrete cracks are developed. These cracks may lead to corrosion and the capacity of the member may reduce in long term. While we can see in the rightmost diagram, CFT, the outward buckling is observed but inward buckling is not observed, which results in the failure. So we can say that inward buckling is the main reason of the failure of the steel tubes. While in CFT, due to packing of the steel, the cracks are not developed and risk of corrosion is negligible. The various tests has been performed in the steel tubes and RC and CFT. which we'll be seeing further. In all the results, it has been observed that CFT is far more better than steel tubes and concrete structures. As we can see in the graph, the load bearing capacity of steel tubes, RCC structure, and CFST have major difference. CFT is far way better than steel tubes and concrete structure in bearing capacity. The axial comparative behavior graph have also been observed in which CFST has been widely overcome the load bearing capacity. As we can see, CFST comprises of two members. First is steel and second is concrete, which we will discussing further in our presentation. First of the member which plays a vital role in CFST is steel. Mild steel, high strength steel are widely used in CFST. There are minimum guidelines which should be followed while making of CFST, which are shown in the slide. The determining is also being done by D by T ratio, which is also depicted in the slide. The D by T ratio for the rectangular section is also represented in the presentation. The second member used in CFST is concrete. There are many type of concrete which we study in civil engineering, but in which the concrete used in CFST is self consolidation concrete. This concrete is preferred over other concrete because of its high strength and less corrosion properties. There are also limits for the water cement ratio should not exceed 0.4. This is mainly done because if the water cement ratio may exceed 0.4, the volume change may more occur in CFST, while in the case of CFST there are less vent holes which may interfere the volume change and may result in the load bearing capacity of the structure. The another type of CFST which is widely used nowadays is pre-stressed concrete fill steel tubes. It is similar to pre-stressed RCC columns. The technique here is similar. The load carrying capacity of CFST in comparison to pre-stressed CFST is far way better. The pre-stressing strands are introduced in CFST so that the strength of the member is increased. As we can see in the diagram, the anchorage blocks which are provided so that the cables or the strands are pre-stressed with help of them. There are various advantages of CFST which are displayed. Main of them are, first of all, the local buckling is avoided in CFST, which is very dangerous as it is causes fatigue failure. The strength of concrete is increased due to confining effect provided from steel tube. The creep of the concrete is also overcome through the use of CFST. Fire resistance property are major advantage of CFST, which reduces the case of failure of the member in fire conditions. In comparison to the steel and RCC columns, CFST are 62% less weight than the RC or concrete columns, which provides us a major advantage over concrete columns as they can be many ways to design the CFST due to its light properties. Due to its lightweight structure, it is also very much resistant to the earthquakes. These CFST can be used in seismic regions without any problem, and the brittle failure is also prevented. The cost of the CFST in initial stage is very high, but in long term it is far way better than RCC or steel tubes. There are many limitations of CFST due to which its use and awareness of CFST is much less in today's world. First of all, the knowledge of the CFST is limited. That means the CFST know various type of knowledge and its theory have not been published in the market today. There are combination of two materials, that is steel and concrete, which can be a problem because the combination of two dis- have many different properties which needs time to be studied. Majority of tests have been done, but the assurance of safety of CFST is still a doubt in many people's mind. As we proceed further, there are various case studies which I have performed while studying CFST and making its presentation. Application of CFST is mainly done on the sites where heavy load bearing is being done. CFST are used in high compression capacity and ductility region, which we'll be discussing on further. The CFST is mainly used in China, and one of its example is Wangchang East River Bridge. As we can see in the photo, the CFST tubes in form of arches have been provided in the diagram or the bridge. Due to its molding ability, the there is no requirement of the molds which we use in RCC columns, which decreases the cost of the CFST and ability of molding anything in any shape. The another example of the CFST is Canton Tower, which is currently the fourth tallest freestanding structure in the world. Its height is 604 meter. Structure consists of space lattice composite frame in which 24 CFST members have been utilized, which have maximum dia of 2000 mm and wall thickness of 50 mm. The live photo of Canton Tower have been depicted in the slide you have been seeing. As we can see on the rightmost diagram, there are vent holes and manholes which are provided in the CFST. These holes are generally provided so that while filling the concrete in the steel tubes, there are volume change and air bubbles which are generated. These holes help to provide the air gaps and the air released in the filling of the concrete to escape. The, the Canton Tower cross section may be divided into chambers, the longitudinal stiflers and tie bars, and internal diagram. Several vent holes, as I have discussed, is also being provided in these CFST. The another outstanding example of CFST is Ghanai's, Ghanai's Bridge, China. World longest CFST truss bridge is located in China. Its total length is 1811 meters, which is amazing. The pier height is 110 mm. As I have shown in the slide, these are the photos of the bridge located in China. The orange tubes which are depicted in the photos are the CFST. As we can see in the photo, the wide use of CFST providing high bearing capacity to the bridge. The another photo of the bridge depicts how long the bridge is and how much weight these CFST columns are carrying. So reaching to the conclusion, I would say the CFST are one of the emerging technology in civil engineering today. The scope of CFST have been widely used by the researchers. The characteristic and the structural properties are impressive and they may overcome the use of RCC and steel tubes in future. Studies and feasibility of CFST must be taken care so that we can overcome the problem of less bearing capacity of steel and concrete tube. So finally, I would like to end my topic Thank you for listening. The end.